Creating a video. This is Geometry, Unit 3, working on angle pair relations. We're going to look at our proof. What we want to prove is that line P is parallel to line R. And for us to do that, we need to come up with one of our four ways. And we need to show that these are congruent. It looks like to me we're going to talk about alternate interior angles are congruent, then the lines are parallel. That's what we want to get to. What we know for sure is that G and H are parallel, and 1 and 2 are congruent. So what we're going to be able to see is that 1 and 3, they're going to be congruent because corresponding angles are congruent if the lines are parallel. Then we'll be able to show 4 is congruent to 3. Or we could just go straight to 2 because corresponding angles are congruent. So let's give that a try. G is parallel to H. Angle 1 is congruent to angle 2. That was our given information. We first started with a plan. What we know is that the two lines are parallel. What we're trying to show right now is that two angles are congruent. If lines are parallel, then these types of angles that they're called, okay, remember this, anytime you see lines are parallel, you're supposed to be looking for one of these four types of angles. So the angles that we saw were 1 and 3. Then corresponding angles are congruent. So that shows us that these two angles would have to be congruent. Now this proof is actually taking us a little farther than maybe what's necessary. But this proof is asking us to talk about some vertical angles. So angle 3 is congruent to angle 4. Now we know that 1 is congruent to 4. If 1 is congruent to 3 and 3 is congruent to 4, then 1 is congruent to 4. That's the transitive property of congruence. If A is congruent to B and B is congruent to C, then A is congruent to C. Notice that three-step process for us to prove congruence. Now look here at this time. They have put another piece of given down here. So actually, they wanted us to split this up. They wanted us to write this given information. We haven't used that yet, 1 and 2. They wanted us to write that given information later on in the proof. That's what that given down here would mean. Because now we can do another transitive. And we can show that angle 2 is congruent to angle 4. And if alternate interior angles are congruent, then the lines are parallel. Remember, the if has to come earlier. 2 and 4 came earlier. 2 and 4 are alternate interior. Then is happening right now. Then are parallel lines. So this really helps you understand what the statement's going to be if you look at what's happening in the proof. And we'll flip it over. We're going to try the same proof again, the exact same proof again. But this time we're going to do it with less steps. We're going to combine more things together. Okay? I don't expect us to go vertical. I expect us to go corresponding. That would be the quicker method to get through this. I believe this time we're actually going to put both the givens on the same step because that's okay to do. I like to separate them, but there's nothing wrong with stockpiling them all in the beginning. So again, angle 1 is congruent to angle 3 if parallel lines, then corresponding angles are congruent. We have corresponding angles, and they have to be congruent if the lines are parallel. All right? We also know that 1 and 2 are congruent. So if 1 is congruent to 3 and 1 is congruent to 2, 2 has to be congruent to 3. That's the transitive POC. So now if 2 and 3 are congruent, those are corresponding angles, I know that P is parallel to R if corresponding angles are congruent. Then is happening right now. Then lines are parallel. So that was the same proof, just done in less steps because we combined and we stayed away from the vertical angles to talk about alternate interior. Just another way to do the same problem. All right, we're going to slide down to number 4. We see that these two rays are perpendicular to each other. What we need to prove is that the two angles add up to 90 degrees, that they are complementary. We need to show that 7 and 8, angle 7 plus angle 8, are complementary, that they add up to 90. So to be complementary, already given that away, it adds up to 90. So we're going to have to get adding up to 90 first. And then we can show because they add up to 90, they are complementary. So ray ED is perpendicular to ray EF. That was our given information. We know that for sure. If perpendicular, then right angle. We have right angles since we know we have perpendicular lines. If right angle, we know we have a right angle, then 90 degrees, then its measure is 90 degrees. That's what we have here. So we know this big angle is 90 degrees. We know that this big angle is the measurement of angle D. I guess we can say the measure of 7 plus the measure of angle 8 equals the measure of angle DEF. We know the small angle plus the small angle equals the big angle. That's called the angle addition postulate. We're adding up two small angles to equal the big angle. Substitution. Look at what DEF equals. The same thing. So we can now say that the measure of angle 7 plus the measure of angle 8 is 90. If two angles have a sum of 90 degrees, then they are complementary. Notice I did not say 7 and 8. You don't write that as a reason. You don't say 7 and 8 are complementary. You just say the angles are complementary. And that's it. That's all of it.